Before we actually do the procedure, it was asked of you to actually do the pre-lab questions. Like it says right here, it must be completed prior to conducting the experiment. The reason why we do this is to get you thinking about what you'll be doing in the procedure and also in the calculation section or the analysis section of the lab. So in number 1, you were asked to find out how many moles of cobalt are present in a 200-gram sample. This is exactly like one of the example problems that we did in our notes. So the very first thing that I did in this calculation is to first figure out the formula. Then I had to find the molar mass of my compound. So I said, well, I looked up those molar masses from my periodic table, totaled them, found it to be 129.9 grams per mole. To determine the percent composition, I then take my individual masses, divide them by the total, and those are my percentages that I got for each of the elements. After I've done that, I need to take my percent of cobalt, which is at 45.4, multiply it by the total mass of my sample, as you can see in the typed question up above. It's a 200-gram sample. You multiply them, you get the mass, which is 90.8 grams of cobalt. Now the question asks for the moles, so it's one extra step because we probably will be doing something like this in the conclusion section of this lab. You take the mass, divide it by the molar mass, that will give you the number of moles of cobalt in this calculation. The other 2 questions were written. It's asking you if the heating of a hydrate what that will do, what's the reason for doing this lab. It's because we want to drive off the water that's trapped in the crystalline structure of this hydrate. So heating it will cause the water to vaporize. That's what I said. The 2 reasons why we should never touch the crucible. The first one is your heating it makes it hot, so don't touch it. You don't want to burn yourself. Crucibles will actually get very, very, very hot. You talk about a 3rd-degree burn in a matter of seconds. Now, as far as the other one, it's because if you touch your fingers onto a crucible, you're contaminating the crucible and adding mass to it. You don't want to add any mass to the crucible if you can help it because it throws off your results. All right, now we're going to start the lab. Today's lab is the dehydrating of copper 2 sulfate. The materials that you'll be needing are 2 sheets. You should already have the procedure in front of you, and you can read through the different steps that follow. I'm going to be doing most of these on camera. You could probably read through some of the background information or the introduction information and the safety warnings for this equipment as well as the chemical. There should be some pre-lab questions that you completed, and if you had questions you can email me over the weekend. And then afterwards we're going to be filling in this data table. Now the very top of it, as it says right there, is the data we're going to collect during the procedure. The other section is the calculation section. This is where you will fill in all of your answers. The answers I'm speaking of are in the questions that are on the back side of the paper where it says calculations. So as you go down, step number 1, 2, 3, 4, 5, 6, and 7, and then also 8, all of these are where you show your work for each problem, which then gets filled in on each of these blanks here. The very last thing is that value right there is what we're looking for as far as a hydrate is concerned. It's always surrounded by a certain number of water molecules. You need to determine that number of water molecules that comes from question number 8. The value that you will fill in here, like it says right here, your instructor will tell you this value. It is 5. I'm telling you it right now. The copper sulfate should be a pentahydrate. And you're going to do the calculations to see if you actually got a pentahydrate from the lab procedure that I will perform right now. So with no further ado, let's actually do this actual procedure. So the very first thing is I want to determine a clean mass, or the mass of a clean dry crucible to the nearest 0.01 grams, and I want to be careful when carrying this crucible. So I'm going to go and carry this crucible to the scale. So here I go. So my mass is 23.55 grams. Whoa. 23.55 grams for the empty crucible. It's already clean and dried out. I did it ahead of time, so it's all ready to go. The next step is to take my, you see I can record my 23.55 grams of an empty crucible. I want to measure out my copper 2 sulfate, approximately 3 grams of it into an empty crucible. So that's exactly what I'm going to do right now. As far as the copper 2 sulfate, if I look right here, it's a bright blue crystalline solid, and I'm going to scoop up exactly 3 grams of it. The easiest way to do this is to just, well, add 3 grams approximately to the 23.55 grams. So we're looking for 26.55, but if we're not exactly there, that's okay. Oh, 23.55. I'm breathing on it, so let's stop breathing. All right, whoops. I measured out 27.09 grams, so I'm a little bit beyond the 26.55, but that's okay. I'm going to now record my 27.10 grams, okay, 27.10 grams, into my data table, 27.10 grams, and now I'm going to mass out my hydrates, or do the mass of my copper 2 sulfate hydrate used. I just have to do a little subtraction. I'm hoping that you can figure that one out on your own. Now let's continue on with the observation. Okay, I'm going to make some observations here, just like so. Up, I'm touching the crucible like I'm not supposed to. Alrighty, so I go and make my observation of the copper 2 sulfate before I heat it, and now we're going to start cooking. I have my Bunsen burner. It's slightly dirty, as you can see at the very top of it. I have it connected to my gas valve. My gas valve is a ball valve. All I have to do is crank it towards myself and it's full blast. I don't want it to be too high, so I'm going to turn it down just a tad until I barely hear it hissing. Alright, so I got my gas here. I'm going to try to do this one-handed, see if this works. Oh, and then I got my mass. I got my fire. So I got my Bunsen burner burning, and what we want to start doing, like it says in the procedure, is to heat the crucible gently. Alright, so the crucible should be in the flame and we're going to heat it gently. So first thing I want to do is just get it toasty warm. So I'm just taking the flame and, as you can see right here, kind of tickling it. Alright, just trying to get it up to temperature so we don't shock it with a lot of heat. So as I slowly heat this up, I'm doing this for, well, let's see, approximately 2 minutes. Yep, I'm still heating. And if you want to try to make an observation, I can't get too close with this flame there. I can hear it sizzling just a tad, just from the moisture that's in the salt itself. So I'm going to let that flame sit there like it's been 2 minutes, and we're going to let it cook. And I'll come back. Now that we've actually been cooking this for a long time, I'm heating it very vigorously with that hotter flame, and it's just getting in contact with that the bottom of the crucible. I look at my blue crystal, that it was once blue, now it's completely dried out, it's dehydrated. I have nothing but white crystalline. It's a chalky solid. It's not the same appearance as what it was when it was a bright blue color. It was kind of pretty back then. Now it looks, I think it's reminiscent of like kitty litter. So I'm going to take this and bring it down to my wire gauze to let it cool off. I'm going to turn off my flame because it's been completely dehydrated, and I'm going to let it cool off for a little bit. Now I moved my crucible, it's been cooling off for a while, over to the weighing dish, or sorry, the scale. The digital scale now reads 25.77 grams. Now that's the mass of the crucible and the copper sulfate after my heating. And if I make my observation again, if you want to take a closer look, there is my copper sulfate. It's got more of a chalky white substance to it than anything. It's not a pretty blue color anymore. So this should pretty much finish up your entire procedure. There's really nothing else to do other than cleaning up. Like it says at the very bottom, chemical disposal, and I'll take care of that off camera. You have the work ahead of you to actually calculate. Your calculations section, you should have everything filled at the very top. I left all this stuff blank, but again, I could probably fill in my 25.76. 25.76 grams of my crucible and my copper sulfate after I heated it, so it's completely dried out. Now from there, fill in your observations. Like I already told you in the video, if you did not catch that, rewind, go back and watch it again. The rest of the calculations, take a look at those on the back side. And all I will give you as hints here is you're using stuff as far as like the gum lab that we did ahead of time. All right, a few days ago we did the gum lab. This is doing percent composition with using a sample. Remember, you're just doing a percent composition with a sample from the lab. You recorded all the masses at the very beginning of this procedure. And then the rest of this is mass, moles, molecules. So you're going to need molar masses from your periodic table for the particular chemical that you're dealing with, either water or copper sulfate. And then from there we have some ratios to deal with. If you have questions, ask me about it over the weekend or come and see me. As far as the rest of this calculation, I already told you the ideal value is 5, so you're going to compare it to the values that you get here. You should get somewhere near it, but if not, maybe I did a crappy lab. And the rest of this is telling me 2 sources of error that could possibly happen. I want to stress to you that you're not just telling me the 2 possible sources of error, you're also explaining to me how this would affect your mole ratio, meaning number 7. How does that affect the numbers that you got there? Other than that, you should be all good to go, and I'm going to stop talking now and enjoy the rest of my weekend. All right, talk to you later.
Inflatable pool full of dad's hot air. Well, I was 3 years old, splashing everywhere, and so began my love affair.